Hello everyone, this is the video lecture for Calculus 2, section 7.4, partial fractions. I even have in my notes right here, yay! Do you remember these? So these partial fractions go way back to Algebra 1414. And I think we hit them up along the way, like in pre-cal maybe, can't really remember, but other places. I'm going to give you my rules and guidelines, and I'm going to show you how some of those fail even in this class, but that's why they're rules and guidelines. They're not, well, they're rules and guidelines. So, rules, guidelines. Sometimes they fail, but rarely. I'd say very rarely, and I'll point out where that happens. Number one, the numerator is one less degree than the denominator, is one less degree than the denominator. I'll explain all this here in a second. Descend the powers. Descend the powers. Okay. What does that mean? I don't know yet. Number two, repeating factors. Repeating factors in your denominator. Like, so if you have repeating factors in your denominator, you're going to use the least, what did I say, least complicated? The least numerator? Least complicated numerator. Numerator possible. And descend powers. Okay. What does this stuff mean? I'm really hoping you remember some of this. I'm expecting that you don't. So let's just get it out right now that even if you were to understand what I'm saying right here, and it's doubtful because who knows if you had me or not, and it's been so long since you've seen this before. So I'm going to say this one more time. Numerator is one less degree than the denominator. Descend your powers. And then rule number two is repeated factors in the denominator. If you have this, then you're going to use the least complicated numerator possible. Descend the powers. Okay, let me give you what these look like. And again, I am hoping that you've seen this before, hoping that you recognize all this, but I'm not assuming that you have it all. So, so we say we have something like this. And this is going to be one of these partial fraction things that we're trying to do. The numerator will be one less power than the denominator, one less degree. So here we got a 2 power, and so here we have a 1 power. It would be similar if you had, say, in the bottom, a cube, blah, blah, blah. Well, on the top, you're going to start with a square. Now, I always say a, of course, that's what they're going to want in WebAssign as well, a, x squared, and then you descend the powers down. So notice that this went to a 0 power here, and so that's what I'm going to do here, b x to the 1, and then c x to the 0. We don't have to write that 1, and x to the 0 is just 1, so you don't have to write that either. So again, I'm descending my powers. Okay, so 1 less, descend down all the way. For the other guy, let's say that I have a repeater in the bottom. Let's just do this guy cubed. And so how do I work with this guy? I put my cube first, and then I have my square, and then I have my regular. That's a 1, and then basically you're done. There's nothing else to do there. So again, I'm descending my powers. That's what that right here is. So descend the powers here in the numerator. Here I'm descending my powers in my denominator. So if you ever have this, you also have to include the second one and all the way down. for those factors. But it says use the least numerator possible, least complicated numerator. So what would this guy here have? Notice it's just x to the 1, so we got a 1 power here. Therefore, you're going to have an x to the 0. Again, 1 less. But anything to the 0 power you don't really need to write. That's just a 1. So I'm going to erase that essentially and just have a. Well, the thing is that you don't want to put a way over here, but I'm saying that we're going to have a constant. That's my constant. Just a constant value. And so I'm going to do a here, b, and then a c. I'm going to use the same numerator every time, but I want the least complicated one. See, like, if you had this one here, you would say, that's x cubed, and so therefore I need to start with a square, and then a regular, and then a constant, and I got to take that and put it here and there. No, 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 no. Let's just keep it easy. We're going to start way over here and see what that pattern is, and just use it for all of them. Okay, now, where does this fail? It doesn't really... Fail's a bad word. It would just, it's not always the most handy. There are times where this goes more extravagant than what you actually need, and sometimes it leaves out some stuff that you should be doing instead. Again, I'll be pointing those, I would say those rarities. I would point out those rarities to you as we go through, okay? So 74002. I have x minus 56 all over x squared plus x minus 56, and they say rewrite it with this partial fraction stuff. Now they're just wanting a's and b's. They do not want you to actually solve yet. So this is not too bad, actually. We can do this. I need to factor my denominator and see what I can do. So this is my first setup process of this. Again, I'm hoping you've seen this, but I'm assuming that you haven't. So what I need to do in order to solve, I need to factor the bottom down. And I'm saying, well, what multiplies to 56 but adds up to 1? And that's going to be an 8 and a 7 in this particular case. So a positive 8 and a negative 7. Cool. So this equals that exactly, right? Well, what I want to do is split this up into two separate fractions. I want to split it up with the 8 and the 7 separated. So I got the 8s and I got the 7s, and they're definitely different. They're separated, completely different stuff here. This is what my goal is. Notice that this is a 1 power, so therefore this guy's going to have a 0 power. I just use an A, super easy there. Same thing here, 1 power, and so I'm going to have a 0 power, so it's a B. Again, this 0 power stuff is way too much. You don't need any of this. Anything at a 0 power is just 1. So all of this goes away, and you're left with literally just A and a B, and that is it. So that's actually what your answer is going to be. Let me just write it up here, I guess. It looks just like this guy here. Okay, that's your answer. Like, that's all they want. They want you to set it up, and we're done. Okay, well, this was part A of this problem. Part B is also pretty good, so let's talk about that one. So we got this guy. They want to split it up. Well, I need to factor the bottom, and actually an x squared can come out. Again, that's just a 1 right up there. Well, now I have my two factors, essentially. I have x squared, and then I have this x squared plus 1, yeah? Wrong, because what's going on is that this x squared is a repeater. It's x squared. So then I can also say x to the 1. I have to descend down on repeaters. Now this guy doesn't have a repeater. He's just a plain old factor. Can you see the difference though? It was that I had this x minus 0 squared. So then I have an x minus 0 to the 1, right? It's, and I'm writing a minus 0 just so you can see the expanded form, I guess you can say. It's a repeater. It's a factor repeated. This one's not repeated. It's simply this thing plus 1. It's a little different. Now, I know that it's not factorable. I know that we can't go any further than this, but that's done. It's done. So it's easier to see with human eyes and recognize when you can or can't do something. And so I'm going to say look for the repeaters and do that. If it's just a factoring thing and then you're done, you don't actually have to do anything with that. That looks really bad, by the way. That's actually x squared and then plus 1 like this. Yeah, it's not 2 plus 1 at the top. Anyways, just little nitpicky things there. So you're done there. If you can factor it, cool. If you can't, then you just leave it alone. So looking at these guys, which one would be easier? Well, this guy here is a 1 power, so again, 0 power, blah, 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 just a constant. I would just put an A right here. Well, I want to start with the A right here, in fact, instead, and then B, and then this guy's a little different. Notice that we have an x to the 2, so I have to start with x to the 1. I already used A, I already used B, so let's go ahead and use C, and then I have to descend those powers as well. Now, if you're seeing a pattern here, and I hope you are, the numerator often looks something like this here. That's like a numerator style. I start with this guy and I descend down. It's just a polynomial, right? Cube, squared, regular, constant, that kind of thing. Of course, you would only have this in the numerator if you had like a 4 in the bottom, blah, blah, blah. See how it's, again, that's 1 less always. What I'm getting at, though, is in this particular case, yes, you can do all this, but my method here is too extravagant. I mean, look at all these variables, and it's just really, really hard. Hopefully you don't have to encounter something like that. You won't, by the way. So we'll figure that out all together. And again, let's just keep going. That's your answer, by the way. You're done. So 74005. If this is still confusing to you, I understand. I'm just trying to give you like the layout. And again, I really hope you've at least seen this somewhere back in the day. But maybe not. So I'm okay with reteaching this stuff. Okay. So this one I got wrong. I started doing my own thing and I got it wrong immediately. My first thoughts is that I can actually factor the bottom to have x minus 1 squared, right? I could just rewrite it. Well, then I would say, oh, well, I got a square, and so then I could also then have, it's a repeater, so I can have a regular as well. This one is, this is an easier term, so he's going to just have a linear A right there, so I don't want to use an A yet. I want to use an A over here, so A, and then a B, and then that's it, right? We're done. Wrong. They don't say they'd want that at all. It's similar, but there's a little bit more that we have to do. I want to show you their answer. Their answer is x squared plus a over x minus 1 squared plus b over x minus 1. Now look at the difference between mine and theirs. See this? See this? What's the difference? There's no difference. They're the same. The only difference between these two answers is that they included this guy. So where did he come from? What are we doing here? I thought I was just applying the rules and walk away. Well, we haven't actually solved any of these yet. And I have this huge set of notes about why we would do this versus that. I'm going to go ahead and do it. But this is a weird problem. And I've gone through, and maybe I skipped a weird problem. I don't know. But most of the weird ones I've done, and this is one of them, and that's why we're just talking about it. So where did that x squared come from? What are we even doing here? Well, let's start back with what we had. What I actually had. So we have my really big numerator. And I said, hey, this is my repeater stuff or whatever. So I'm going to have my repeater descend its powers, and I have my A and my B, right? That's what my answer was without the x squared in there. This equals that. So when I multiply it over, what I'm going to get is x to the 4th minus 2, excuse me, x cubed plus x squared plus 9x minus the 4 is equal to, and now when I multiply it to both of these, I actually get this in the numerator, and these guys cancel, leaving it as a plus a, and up here I got a b times x minus 1. Let me try to do that minus a little bit better there. So I'm looking at this equals that. This equals that. And it could, I mean, in theory it could, but where's my x to the 4th? Where's my x cubed? Like, if I distribute this, wouldn't I get just bx minus b? And if the, oops, sorry, that's a plus sign. And if my a and b are just constants, then, like, I guess the only thing I can really solve for is this thing. where are all these terms? Where'd they go? That's supposed to be a question mark. It is just a really bad question mark. In a way, I'm saying I'm lost. I don't know what to do. It doesn't make logical sense. So instead, what do? They use long division, not log division. Long division. And I'm going to actually do long division with you on this. However painful this is, painful because it's long. That's why they call it long division. Did you know that? Let me just rewrite this up here, and hopefully correctly so that I don't make a mistake. Okay, so long division. I'm going to start using a little bit different colors here. I got my first terms off to the side, divide them. I get an x squared out of that. X squared goes up here. Multiply by each one of these terms and bring it down. X squared times x squared is x to the 4. X squared times this guy is a negative x cubed. And then x squared times the 1 is going to be a plain old x squared. I'm going to change the signs. Hold on, change the signs. That's going to be a minus sign now. Zero it out. These guys actually zero out as well. Is that what I got? Yeah, that's what I got. And these guys zero out as well. That's happy, I guess. I don't know. So I got this guy. I guess I could even move down this guy or whatever. That's my remainder. And so you can see already that my answer to this long division is just simply x squared. And then I have my remainder of x minus 4 divided by this x minus 1 squared. Now, where did that guy come from? It's this guy. This is the same as this guy. I just re-put it in that format. So then I want to split that repeater up. And so then I've got my x squared. I got a over the x minus 1 squared and a b over the x minus 1. That's how they finally got it. Okay. So, would I say that this is actually a good problem? No. Would I say that this problem is actually helpful for you understanding what's going on here? No. But we did it together, and that's okay. There's still a part B to this. I got x squared minus 1 all over x cubed plus x squared plus x. And what I want to do is factor the bottom first. They all got an x at least, so x squared plus x plus 1. I can't factor that down anymore, and so I actually just have the two factors here. And so here, it's a constant term in the top. Notice I got a 2, so therefore I'm going to have a 1. And then, of course, I descend down to the constant. And that's the answer. That was it. Pretty easy now. So we have not solved any one of these. Nothing. We've just set it up. It's sad that we're not even solving this stuff. I could. You'll probably get crazy fractions or something. But, again, they don't even care about that. They just want you to set it up. So I'm just doing that. That's what we're doing. And now we're going to actually solve on the next problem here. So just going back to my rules, my guidelines. In the numerator, it'll always be one less than the denominator. So again, my denominator is the factors. I find what that degree would be, and I go one less, and then I descend down. So again, I start with like a 1, and I go down one constant. I have a 2, and then a 1, and then a constant. If I had a 3, did I have a 3 somewhere around here? I thought I did. Okay, maybe I got rid of it. But a 3 goes to a 2, goes to a 1, goes to a constant, etc. Repeating factors in the denominator, again, if you have a power like a 2 or a 3 in the denominator, you need to use the easiest numerator, and you need to descend your power. So I got a 3, so that means I got a 3, a 2, and a 1. This guy would have just a plain old constant, so I go back and say, constant, constant, constant. Or whatever it would be. Normally it's just a constant. Okay. That was a lot of work. We have not even done calculus yet. Yeah, we were just doing setup problems. Integral from 0 to 1 of 12 over 4x squared plus 5x plus 1 dx. Solve. There is a way to get this done with formulas. I know it. There are formulas somewhere in that formula book that'll just do this. But like, there's 100 formulas. And I don't think you're going to put 100 formulas on your note card. My point is that we need to be prepared for anything out there, and it could just change it just slightly, and then your formula is all of a sudden not going to work. So, also, how did they make those formulas? And what if I just don't find a formula that works for this? Like, this one is fine, but what about a cube? What about a fourth power all of a sudden? And then it won't work anymore. I have to go do my own thing. So let's start training ourselves on how to do this. Except for the integral stuff, this part here we've seen before. And what I want to do is split this up into two different factors. And in fact, the two factors are not too bad. We are in Calculus 2 now, so I'm just going to say, hey guys, look, it's 4 and 4 plus 1, and it's the 1 and 1. Basically got 1 times 1 is 1, 4 times 1 is 4, 5 makes a 4 and a 1 put together, and that's how I got them. Factor it, blah, blah, easy. Okay, this guy has a 1 power, so I'm going to have a constant term in the top, just an A. This guy has a 1 power, so therefore it's a constant in the top, just a B. And this is my guide, my guideline stuff. And what I want to do now is solve this. Solve, okay? Once I solve this one, this is the first time we're doing this, because normally we just say, hey, we're done. Now we're going to solve it. Then after we solve it, then I got to go back and integrate. This is actually a whole lot all at once. It's like, okay, you had the bicycle with the training wheels, right? Cool. And you're okay with that? Okay, let's not just take off the training wheels, but let's step you up to a mountain bike and send you down the side of a cliff. So you'll be fine. So that's what it feels like to me here, and that's this section. So let's solve. So in the very beginning, what I actually had were these two factors put together with a 12 in the top. My result, I'm hoping, will give me these two separate factors as two separate fractions. This right here is what we were trying to do all the last set of problems. This right here is what we're trying to solve here. As in, right now, solve for A and B. So how do we do that? I'm going to take these denominators and multiply them over, leaving just the 12 over here. When I multiply both of these into the numerator, what actually happens is that the 4 plus 1s cancel each other, leaving only the x plus 1 left behind. Same thing on this side. I have the 4 and the 1 both up here. Well, the 1s cancel, leaving only the 4 behind. And so what I often say is that whenever you're moving them over, you end up multiplying by their opposites. You see how A had a 4, but now it's being multiplied by the 1. B had the 1, now it's being multiplied by the 4. So that's just another way of expressing it in English. So you move it all over and you multiply by their opposites. I want to keep simplifying, so distribute your A and their B. So I got AX plus A, and then I got a 4BX plus B. And this is still just all equal to 12. Just going to remind you of that. You don't have to go this far, but I'm going to go this far because I like to. I'm going to factor all my x's together. And so I basically got A plus 4b x. And then my constant terms, I have just A plus b. Cool. Again, this is still all just equal to 12. Well, here, just pause for a second. If you know anything about this, I guess you can already kind of jump to some conclusions. But I'm not going to assume that you already know this. I'm teaching this fresh to you. I hope it's appreciated, not just boring. So there's no x's on this side. So I'm going to create x's. That is right, 0x. Because technically, how many x's do we have on this side? And you would say, well, 0, none. That's exactly correct. But now what I've done is been able to combine like terms. So 0 equals A plus 4b, and 12 is equal to A plus b. Notice that this 0 is equal to this guy, because their x terms should equal your x terms. Here you got your constant terms should equal your constant terms. Okay, your constant can't affect an x, and your x can't affect a constant. So I'm just putting them in their categories, into their groups. And now we solve for a and b. Do you remember matrices back from college algebra? Oh yes, you could totally use matrices here. You would have 1, 4, 1, 1 augmented with a 0, 12. And how do you solve that? You use RREF, and you get your answers. 16 and negative 4 will be your answers. I am not going to do that. I am not going to do that because, for one thing, it was so specific. And yes, it is handy. It comes in handy right here. Obviously, you got your 2 answers. Cool. But, like, how long has it been since you've done matrices? Not let alone this this partial fraction stuff. So if you hadn't seen that, goodness me, if you remember all your matrix stuff, I'm not going to do that. I'm going to solve this using that substitution method stuff or whatever you want to do. Lots of different methods. But here, I just want to solve this. This is nice. We like it, but it's so specific. Let's go and do our own thing now. I'm going to move the b over, and so I have a is equal to 12 minus b. I'm going to take that and plug it in right here. Okay, so I got 0 is equal to 12 minus b plus 4b. Okay. Combine like terms, what you actually end up with is a positive 3b. Move the 12 over, divide by the 4, and your b ends up being a negative 12 over 3 is a negative 4. And that's what we were getting over there. I can now take that and plug in to solve for a. So then a is equal to 12 minus a negative 4. Well, then a, if you do the math there, is actually equal to 16. And so then I got my b is equal to negative 4, my a is equal to 16, and I should now finally be able to go back and say, well, the 12, and the 4 and the 1 should all equal now, again, a and b here. Make sure you're putting these denominators in the correct place. Man, if you flip these, the whole thing blows up. Just be careful about what you originally had written. Actually scroll back up and say, oh yeah, that's what I'm looking for right there. Copy, paste. And then that's your A, and that's your B, and we're cool here. Yay! Well, you're not done. Nope, you solved it. Great job. Now you still have to integrate from 0 to 1. You're going to integrate this guy from 0 to 1. Now you're going to integrate this guy from 0 to 1. I'm going to put a minus right there. Makes it look fancy. Okay, this is actually super easy to do, so we're going to work on this together, of course. Each of these is going to be an ln. It's just 1 over stuff. Now, you got to do the u substitution and stuff like that. In particular here, u is equal to 4x plus 1. Du is equal to 4dx. So dx is equal to du divided by 4. So you can see that I have that divide by 4 business going on. That's going to be important. Here we go. Here's my answer. So I've got 16, and then I'm going to say times, come on now, times 1/4, and then I got my ln of the 4x plus 1 minus sign. I got my 4 in the front. Now this one doesn't need the u du so much because that's a 1. You divide by 1, it doesn't really change anything, so I'm just going to go ahead and put this guy here. Plus c? Well, hold on. We still have got a definite integral from 0 to 1, so we'll actually plug that in here in a second. Cool. Well, this ends up being just a 4 in the front anyways, but whenever I plug in a 1, I get stuff. When I plug in a 0, it's kind of funny here. Let's just see what happens. 0 plus 1 is a 1. ln of 1 is a 0. Yes, so then the 0 here, when you plug it in, you get values on the inside, but ultimately it'll 0 out. You don't have to worry. So 16 and 1/4 makes a 4. Ln of basically plugging into 1, we get 4 plus 1 makes a 5. Minus, and then 4 ln of plugging into 1. 1 plus 1 is 2. And then, like I said, the rest of it just zeroes out. So this stuff minus 0, and then, well, that's your answer. You're done. Finally. Whew. Man, that was a long problem. And yeah, it was like basically number 3 or whatever on your homework. I don't know if it was number 3, but like the point is it's early on, and we got a lot more to go. So with that said, I will not be able to do every single interesting problem in this section. And there's a couple sections in this class that are just like this. They're so long, and they would take so long to do every problem that, for one, you would get bored, and 2, I'm going to go nutty. So you don't want that to happen. I would say take a break in between. Don't try to knock it all out, even in one day is maybe too much. I don't know. This is still a fast class. It's pretty tough not to always have to do math here. But I'm going to do as best I can, and I'm hoping that you do so as well. So 0 to 3 of x squared plus x plus 1, all divided by, I got x plus 1 squared, and then x plus 2 dx. Now, is there a formula for this? No, I don't think there's a formula for this guy, and that's kind of my point. So we're going to do the partial fraction thing. Notice that they already have the factors available for us, and so I know that I have this x plus 1 squared. Well, guess what? That's a repeater. And so I have its single term, 1. And then I actually have this guy right here by himself. Doesn't really change. Because these are repeaters, I go to the simple numerator. This would just be an a right here. So I'll just start with an a there, then a b, and then this guy's simple. He's a c. Okay, so again, these numerators are the same regardless because I focused on this guy to tell me what that numerator should look like. Okay, so this is what we have, and this equals, again, my original. So x squared plus x plus the 1, all divided by x plus 1 squared, and then x plus 2. So this equals that. Go ahead and solve. So when I take this and I multiply it over here, what I get is a times, and I'm going to do it the long way once. I really hope that you've seen this before because I do not want to do it the long way every time. It is so not friendly. Like, multiply by your opposites is so much better. It doesn't quite, that's not quite a rule here, and that's why I'm doing it the long way for once. But it's guideline enough that it works 90% of the time. Here we go. Cancel. Cancel one of them, and then cancel these guys. It is still multiply by the opposites, but the opposites just look a little differently this time. That's all it is. In particular, you can see that the b retains one of the 1s. That's really what the small exception to the rule would be. Okay, this whole thing is now equal to, I don't know if I should have put an equal sign right there, but regardless, this whole thing is still equal to my numerator, which is x squared plus x plus 1. Wow. So what do we do here? You guessed it. We're going to simplify. Yep, distribute. Here, actually, we need to FOIL this thing out before distributing. This guy, he needs to FOIL out as well. And yeah, that's what we're doing here. Welcome to Calculus 2, where we don't actually do calculus. I didn't just say that. My bad. X squared plus 2x plus 1. Still all equal to that stuff. I can now distribute. And so then all my x squared terms come together to make a b plus a c. All of my regular x terms I have right here, here, and here. So then I got an a 3b, and a 2c. And then all my constant terms are here, here, here. And so then I have 2a plus 2b plus 1. And this is still equal to x squared plus x plus 1. Note some things. This is a 1. This is a 1, and that's a 1. So this term right here equals 1. This term right here equals 1. This guy right here equals 1. 1, 1, 1. Awesome. How does that help us? It doesn't. Well, it doesn't hurt us, at least. So, yeah. This, in particular, is probably one of those times where a matrix calculator would be very handy, because instead of having to compute every single one of these things... Hold on here. That's a C. That's a C right there. That's a C. See, C multiplied, C. Okay, I figured there would be a C there. Sorry, I messed up there. Okay, so you can use a matrix calculator here for sure, or you could solve. To solve, you're going to move the C over. Let's say I got a B is equal to 1 minus C. You can take that and plug it in here. And so then you got A plus 3 times 1 minus C plus 2C is equal to 1. Distribute. I'm hoping that you're getting some enjoyment out of all this. Minus C equals a negative 2. Let's move the C over. So I got an A is equal to negative C. Let's just do a C minus 2 is good enough. Now I can plug that in here, and I can plug in this right here. And so then I got 2 times C minus 2, 2 times 1 minus C, and then a C should equal 1. Boy, we better be able to solve for C this time. 2C minus 4, 2 minus 2C, plus C is equal to 1. Well, these guys actually cancel. I hope that's a good thing. I take these guys and move them over. That's a negative 2. Now I move it over. I'm going to like plus. So I think we get a 3. Yep, C equals 3. That's what I got. Oh, now I can go back and plug it in here and here. And what I get is my A is equal to 1. And my B is equal to negative 2. Okay. We did it. Whew, man, that was so much work. Not done. Not done. We haven't done calculus at all. Integral 0 to 3 of all this stuff. Now notice again, going way back here, way back right here. This is what I'm wanting to work with. And so my A was a 1. My B was a negative 2, and my C was a 3. Is that correct? 1, negative 2, 3. Yep. Okay. So I'm literally going to take this, copy, paste down there with this exact format. Here we go. Integral of 1 over x plus 1 squared. Negative 2. Got the x plus 1. And then I got a 3. The x plus 2 dx. Thankfully, each one of these is, well, a lot of these are going to be the ln's. This one's a little bit different. But we should be able to do this now. Let's figure this thing out. The very first one is a little strange. What I'm going to do instead is say negative 2. The rest of them, honestly, are very easy. I'm going to say 2 ln of the x plus 1. And then here we got a 3 ln of the x plus 2. Cool, plus c. Well, we're going to have a definite integral here in a second anyways. So I still need to figure out this integral here. So then you could do u substitution, but notice that we get a 1 right there. And so I got my my powers a negative 2. I'm going to add 1 to the power, divide by that new power. And we already knew what u was. And so then I could say, that's a negative over x plus 1, just like this. That's a negative power, so he's in the bottom. I didn't move a negative 1 up. I just moved the negative to the front and then up to the top. Okay, so it's not like I flipped them or something like that. So we got this guy, and we got the rest. And now we're done with our integral. Wow, man, that was so awesome. Plus c. Nope. This is a definite integral, 0 to 3. So plugging in the 3 everywhere, we get something. But plugging in a 0 is interesting. Actually, here we get a value. Okay, so we're going to get a negative 1. So watch out for that. But here when I plug in a 0 here and here, actually nothing happens. Again, ln of 1 is going to be a 0. Therefore, they just cancel. So last bit here. Plugging in the 3. I actually get a 4 in the bottom. Plugging in the 3, I get a 4 on the inside. Oh, ln. And then plugging in a 3, I get a 5. Minus, when I plug in a 0, I actually get -1. So notice again, 2 negatives make a positive. And these constants actually combine together to make 3/4. I'm not going to do absolute value signs. Not required anymore because these are constants. So there you go. We did it. Oh, wow. Yeah, it seems like my answer is different than this. So I missed something. Hold on. I got the 3 and the 5. I got the 2 and the 4. And then I have a 3 and a 2. So where'd the 3 and the 2 come from? I messed up one small thing. This is good. This is good. I missed one very small piece here. So let me just erase this here. We're going to add onto it. I was very hasty. I was very hasty in my eliminating with the zeros and stuff like that. Here, let's use some red. So basically, I said, oh, when you plug in a 0, we get a constant, and then a 0 here makes it ln1. Yes, that's good. But when I plug a 0 in here, I get ln of 2, which does not cancel. So rather than just saying -1, what I actually have now is -0 from this guy. And then here, I got the +3 ln of 2. Still distribute your negative, so we get that +1 to make all that happen, blah, blah, blah. But then we got a -3 ln of 2 as well, okay? So I was too hasty. So let's just say that I went to WebAssign, I typed it in, it says, no, you're wrong. Why am I wrong? So I went back some steps, and I noticed that I had forgotten that little thing, okay? It happens. Okay, cool. Well, we're done with that one. Next one. We're going to be here quite a while. I got plenty of these to do with you. So I got integral of x squared minus x plus 30 divided by x cubed plus 5x dx equals what? So I'm going to factor it. I set it up, and then I start solving. What I want to do on this problem is skip a lot of steps. I want to skip a lot of steps because we've done this a lot, and I just want to get to the end because we've got a lot more to do. This guy factors down here, and so I could factor that to be an x, and then x squared plus 5. And so that's my denominator. And so I can split it up into 2 separate factors. 2 separate fractions for 2 separate factors. And so this is a constant a. Notice that he's a square, so he's going to be a bx plus c. Again, 2. Now it's a 1. Descend down. And now, so we've set it up. Cool. We actually have to keep going on this. I have to solve. And so I'm now saying that I'm going to take my denominators and multiply them over here. So my numerator, my original numerator, is equal to a times its opposite, and then b times its opposite. Well, notice it's not a b, it's like a bx plus c times its opposite. So distribute this way, ax squared plus a, that's, why did I put a b there? That's a 5. Why did I, oh, because I was thinking b. Hold on. See, I got an eraser. Okay, there we go. Okay. So that's a times 5. So it makes a 5a. There we go. Better. I said I was going to skip steps, but apparently I'm not. It's like, hey, we're just going to skip steps. No, I'm not actually skipping any steps at all. I'm just doing the whole problem. Factoring my x squares together, I got a plus b. My constant, or I'm sorry, my linear terms, I got an x times c. And then my constant term would just be the 5a. And so you can see that this is going to be a 1, a -1, and a 30. So this right here is a 1. This right here is a -1. And this here is a 30. You could solve for a lot of this immediately. Like, oh, I don't know, c equals -1. Here, I have 5a is equal to 30, so I divide by the 5, and I make a is equal to 6. Again, very simple stuff here. Here, because I know that a is equal to 6, and this whole thing's equal to 1, so I got a plus b is equal to 1. So I got 6 plus b is equal to 1. I move the 6 over, and b is equal to negative 5. Awesome. And so now I can go back and say now integral of, and, well, I basically copy-paste this guy. So a, and my bx plus c. 6 over x, negative 5x minus 1 all over the x squared plus 5 dx. This is now what I have to solve. How's that any better? Well, they say it's better. I say it's better too. 6 ln x for that one. Pretty simple there. What about this guy? What you actually need here is some kind of a, I don't know. Actually, that's a really good question. What should I do here? I know what I'm going to do. I'm looking at my notes to kind of help me a little bit. I'm going to split this guy up into two separate integrals. So we got a negative 5x over the x squared plus 5. And then I got a minus 1 over the x squared plus 5. So I got two separate integrals here. But this guy's easy. He's done. I don't have to worry about him anymore. This is going to be a u substitution, I believe. So u is equal to x squared plus 5. Du is equal to 2x dx. So dx is equal to du over 2x. So I'm going to just plug that guy in. Let me go ahead and rewrite this ln x stuff over here. Plus, actually, it's going to be a minus in the end, isn't it? So minus 5. I got integral of x over u, du over 2x. Notice that these x's are going to cancel. The 2 is going to come out. So I got a negative 5 halves in the front. Integral of 1 over u du. You've seen that before. It's an ln. I'll get to the other one here in a second. I know I've kind of left it behind. And you know that u is equal to this x squared plus 5 business. Okay, cool. So we got that part done now. Finally, what about this guy over here? It's actually just arctangent. Yep. On previous videos, I always said, hey, doesn't that look like arctangent? Maybe I was right or wrong. I don't know. But this is definitely an arctangent. Integral of this guy's arctangent. And let me show you this 5 here is actually the square root of 5 squared. I know that sounds really weird, but if you go to the formula, what's going to happen is that you got a minus in the front here. And then I have 1 over the square root of 5 arctangent of x over the square root of 5. And then plus c finally. This is not a definite integral. This was an indefinite integral. So plus c, and it's good. Whew. You're like, man, eventually are we going to stop? Good question. So I got the next problem. I'm looking at it. It's right in front of my eyes here. And it, no kidding you, takes 3 full pages of notes. The one after that, I started working, I messed up. That's always fun. And I have to redo the whole problem because I wasn't getting it right. So technically we have 2 problems left. Okay. It's going to be okay. It's going to be okay. So 74033. I have integral of 29 over x cubed minus 125 dx. And this guy, he's so innocent. Look at how innocent. It's like a little kitten. He's not going to harm you. He's not going to do anything wrong. No. It's a really tough problem. And what makes this problem more difficult than others is not only the steps, it's not only what you get out of it and how to factor it and all these other things, but then I got for my A, B, and C, I got fractions, and they're not pretty fractions. They're not like 1/3, okay? We got some crazy fractions. So already I'm doubting myself. And then I go and put all the stuff back in, and it just takes me through a very wild ride. And then finally at the end, I'm supposedly done. Here we go. So I need to factor the bottom. And if you're thinking about it, you're like, oh, well, what would factor this guy? Think about this for a second. What is that cube? That's something cubed. So I'm going to cube root it. What do I get? I think it's 5, right? 5 times 5 times 5 is 125. So what I'm guessing is that one of my factors is a 5. Now, how do I actually get the rest of the answers? I'm going to use synthetic division. Now, you should be happy that we're using synthetic division and not long division. Okay, so I got bring down the 1. So 5 times 1 is 5, plus the 0 is a 5. 5 times 5 is 25, plus the 0 is 25. 5 times 25 is a 125, and they cancel, which I assumed. Good. But my answer now is going to be x squared plus 5x plus 25. Now, I'm definitely assuming you could do synthetic division, because that's definitely something you need to have. Okay. So what I'm going to do is write that as my answer, I suppose, the other factor. And now I'm going to ask you, can I factor that down anymore? Like, what two numbers are going to multiply to 25 but add up to a 5? And you're thinking, well, 5 and 5. No, does 5 plus 5 make a 5? Does 5 minus 5 make a 5? Exactly. It does not factor. Just leave it alone. Plain old 29 still on top, dx. So I have not even done partial fractions. I just did synthetic division. Now, I'm going to have my partial fractions. And it's going to end up looking like this in the end. This is going to be an A, and this is going to be a B. X plus C. Notice that this is a 2, so that must be a 1. Descend down. Yeah, exactly. And so this is equal to that, and now we have to figure out what those A, B's, and C's are. So what I'm going to do is I take this denominator and multiply it over here. So again, as we've seen in the past, A times its opposite, and then B, or Bx plus C in this particular case, times its opposite. Distribute. This is actually going to be a FOIL. Can't get around that. Ax squared plus 5ax plus 25a. I wish I would have skipped steps, because I said I was going to skip steps on the last problem, but I didn't. And now I kind of like put myself in a hole here where I kind of have to do all the steps. That's a good thing for you, okay? Just saying. I said I was skipping steps. I never did. That just never happened. Combine like terms. So my x squares, I got an a plus a b. My constant terms, I got a 5a minus a 5b plus a c. Sorry, linear terms. And then my constant terms finally are to 25a and then minus the 5c. Wow. And guess what? All of this stuff here, does it just equal 29? Yep. Now, I'm going to say that in the past, I would say, oh no, you can't do that because where do you get this x squared? We had a question about this. I think it might have been number 3 or something, where you had to do long division first on this. And you could do that. It might work. I don't really know. I wasn't really trying to do this or not, but it does work in this case. This actually works because how many 29s you got? You got 29. But how many x squares do you have? 0 x squares, 0 x's, and then yes, a 29. So this right here equals 0. This right here is equal to 0, and this right here is equal to 29. And you're thinking, oh, well, that's not a big deal. Equal to 0, cool. Yeah, no, not really. So a is equal to a negative b, and I can plug that in right here. I guess. So then we got 5 times negative b minus 5b plus c is still equal to 0. These guys actually combine to make a negative 10b plus c is equal to 0. Solve for c, let's say. It's 10b. And then I can take that and plug it in here. And I can plug this in over here. And so I've got 25 times negative b minus 5 times a 10b is equal to 29. Yada, yada, yada. My b actually equals to negative 29 over 50. I can then take my c's and my a's and all this stuff here. And so a is equal to 29 over 50, negative positive. We already talked about how they're same thing there. And then my c is equal to negative 145 over the 50. So if you get these answers on a question, don't you already feel like it's wrong? Come on, be honest. Exactly. I think I'm wrong. But you know what? I kept going. I kept going because I said, you know what? There couldn't be something wrong. Not with my math. No way. And obviously that was a huge boast because you've seen me get things wrong all the time already. But I did stick with it and it worked out. So that's good. It's just, my point is that it's scary. It's scary. And you're going to have these problems on your homework. I'm doing your homework problem here. And it's scary. Okay? You're going to have different numbers even. So that makes it even more scary. So I'm supposed to be integrating this guy. Cool. This guy, we've already seen this. Is that going to be that constant up in the front? ln of the x minus 5. Super fast and easy. I'm going to split these up as we've done in the last problem. So what I have here is an integral of x over the x squared plus the 5x plus the 25 dx. And then I have the negative 145 over the 50 integral of 1 over x squared plus 5x plus 25 dx. Phew. How do I solve this problem at this point? So, yeah, we got to talk for a second here, okay? Let's start by looking at this guy right here. And what we did last time was a u substitution. And so what I'm going to assume now, right now, is I have kind of like this u substitution thing going on. I'm like dreading what's going to happen here in a second. I'm only on page 2 of 3 for this particular problem. Wouldn't it have been awesome just to have the book, not have this lecture notes, or these recorded recorded video lectures? Oh, it's all in the book, right? No. So this is my u, this is my du, and I'm going to just attempt this, okay? So I'm just attempting this. Don't overthink it. I'm just attempting it, okay? Oh, that's my u. That's a u du over 2x plus 5. What I'm hoping that you're seeing here is that it does not cancel. These are not going to cancel. Nope, nope, nope. I was hoping that I would just go floop, floop, ln blah. That didn't happen. So what do? Well, I really need this 2x plus 5 up here to make this thing work. And maybe I split these up prematurely. I don't know. So what I'm going to do here is I want to manipulate this guy a lot and see if I can maybe get this answer to work here. So let's just look at, I mean, this is silly that I'm having to do this off to the side here, but just look at this guy here. And I want to get this to cancel somehow. Like, this is not good enough here. I want more. I want to somehow put a 2 there. Let's just start with that. I want to somehow put a 2 there. So I'm just going to put a 2 there. You can't do that. Yeah, you can if you also put a 2 down here somewhere. So what I want to do is I want to multiply this whole thing by 2 over 2. And this 2 is going to go to the top, and this 2 is going to go down here to make a 100. Okay. is this going to cancel out and everything like that? 2x and 2x plus 5, do they cancel? No, they don't. You need a plus 5 now. So how do I get a plus 5 there? What if I just add 5 minus 5? So couldn't I just put that plus 5 up here? No, 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 no. Not quite. This is where things get a little bit more tricky, okay? I do need a plus 5 and a minus 5, but I need it to kind of like be in here. This is actually where that other integral is going to help us out some. And so what I want to do here is something very silly. Actually, I'm not going to use the other integral. I'm just going to do my own thing, okay? I'm going to, in the top here, do some stuff. I'm going to subtract 5, and I'm going to add 5 up here, okay? Now that will give me my minus 5 and plus 5 stuff for sure. I'm choosing to do this minus 5 plus 5 up here because it's going to give me, I guess, that plus 5 right here. But the minus 5 is going to be weird, and we're going to talk about that here in a second, okay? So I know that it looks weird. Just kind of give me a second. So I got a 2x and then plus 5 right here, and then all over this stuff. And I mean, now finally, my integral's looking really good, right? Yeah, not really, because what's going to happen is that I have this minus 5 here I'm going to pull out, and, well, yeah, he still has the same denominator, and that's not very fun. So now I'm looking at this guy. And so this is its own integral, and now this one has its own one. Now that's a third integral, and then we finally still have this guy who's the fourth integral. Just hang on tight. We're almost there. Don't worry about this guy for a second. We're going to come back to him. Let's just finish this one up, and we'll tack it on to what else we already have. So I already said that my u is equal to the denominator and du and blah, 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 and everything's going to cancel nicely so that we get this guy here. That would be just 1 over u du straight up. And so I could just put this in right here inside of my ln. Okay? Awesome. Now, we already had this guy as well. So 29 over 50, x minus 5. So 29 over 50, x minus 5. And then we have this minus this stuff here. Now, that doesn't look very good, so I'm going to do this minus sign right here. I'm going to get rid of this guy. Okay, now that's a little bit more distinct. And we still got more stuff. Okay, so here we go. Plus, now it's going to be minus. Minus the integral of 5 over x squared plus the 5x plus 25 dx, right? This guy. And then we still have this guy up here, 145 over 50 in the front. So 145 over 50, integral of 1 over all this stuff. Dx. These are actually both the same integrals. Kinda. See, here I have a 5, and here I got a 145 over 50. I'm going to have to use a calculator to figure out what the number is going to be here. So I got 5 plus 145 over 50, and I got 79 over 10. I'm looking to see if I have that somewhere on my paper. Nope. Okay, let me just hold on real quick. 79 over 10. I got a 29 over 20. Will that work? Oh. Hold on. No wonder. Hold on. See this guy? It applies to both of them. So he's technically a 29 over the 100 here. 2 negatives make a positive. And so what I'm actually doing here is 29 times 5 divided by 100 minus 145 over 50. And there it is. So this is the same, and now I'm going to combine these two together here to make negative 29 over 20 integral of 1 over x squared plus 5x plus 25 dx. Wow. Now we just got to solve this and everything should be done. Plus c, walk away. How do we solve this one now? Exactly. I mean, I have my notes. I know what to do. I'm just sad that we're having to go through so many different steps here. What you actually need to do here is complete the square. I think we did this on a previous lecture, so I am going to assume that you can do this. And how do we complete the square on this? I don't know, but we're going to try it out. We have this original, and what I'm going to do is I'm going to add box and minus box. Okay? So I take my middle term, I divide it by 2, and then I take that number, and I square it. That's lovely. And then I'm going to add and subtract by that number now. And so what I have is this here, which is what I really wanted. And then I have a plus 25 and a minus 25 over 4, which is the junk that I don't really need, at least in theory. And so this here will turn into a square term. This is actually going to be my x plus 5 halves squared. How do I know? Always, 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 it's this value right here, okay? So you don't have to do any math anymore. It just auto-complete, basically. This junk out here, though, I still have to figure that out. So 25, let me do the calculator. 25 minus 25 divided by 4 is just plain old 19. Is that what I got somewhere, 19? Oh, I messed it up. It's not 19. I did 24 over 4, and that was definitely wrong. 25 minus 25 divided by 4 is that, yeah, okay. Is a positive 75 over 4. Yes, yes. Okay, yep, that's what I got. So far, so good. We're still on the right path here, okay? This still has a multiplier in the front, so I'm now looking at negative 29 over 20, isn't it? 29 over 20? Yep. The integral of 1 over x plus 5 over 2 squared plus 75 over 4 dx. Now, how is that any better to integrate? Right? This actually is arctangent, of all things. So we got negative 29 over 20, just because it's in the front. And it's a U substitution, but it doesn't really affect anything here. What I do need to say is that this 75 over 4 is blank squared. And so to find that out, it's actually the square root of 25 over 2 squared. Notice if I distribute my square to both the top and the bottom, I get my 75 and my 4 back. And so what I'm doing is I'm actually dividing by this value, so flipping it in the front, arctangent of, and then you get your u, x plus the 5 over 2, and then you get this denominator is this guy now, again, so square root 75 all over 2, and then I'll put the plus c in. So here's my final answer. That's the last term. Here's all of my answers put together. Here we go. 29 over 20 ln of the x minus 5. 29 over 100 ln of the x squared plus 5x plus 25. Gone this far, might as well make it look pretty. And now minus the 29 over 20. Oh, and I know it'll simplify. I know. I don't have the energy anymore. I'm literally just going to copy this into WebAssign, and it's going to say, no, you're wrong. I'm just joking. It won't. Not if you type it exactly. Very high probability that there's, if you say it, if it's wrong, then it could be a typo. Who knows? But that is my answer for this one Problem 1. This is worth just as much as question number 1 on your homework. Next question. And the last question that I'll be doing for this section. I'm sure you're thankful for that at least. Integral of e to the x over e to the x minus 3 and then e to the 2x plus 1 dx. Okay, let's just hold up for a second. I could go down the road of how I got it wrong. I actually have a full page of work and then I got it wrong. I got it wrong not just because I typed it in and see if I get it. No, I just saw something that was impossible. It was not working out any better, and I just said start over. And so I started over and doing something else. Okay, so I'm going to actually not do something wrong. I'm going to do it correct. What you need to do on this problem, 74054. This is what you're going to have to do. You ready? You're going to say u is equal to e to the x, and du is equal to the e to the x dx. Okay? Now that sounds pretty easy, like, duh, didn't you want to do that anyways? Yeah, I guess I was overthinking it, okay? So this right here is going to be my whole du, so it's actually pretty simple. And then I'm going to have a u minus 3, and then a u squared plus 1. Now hold on, why do we get a u squared? Well, this guy right here is technically powers of powers multiply, right? So what I'm going to say is e to the x and then squared. See how if I did powers of powers multiply, I go back and get the 2x. Okay, cool. Now, I said I'm not going to skip steps. We got a whole other page or 2 left of this. Is that what I see? Yeah, a whole other 2 pages of this work. I said I wasn't going to skip steps, but then I said I was going to, and I didn't. Now I might actually skip a couple steps here. Everything here is actually pretty basic. I end up getting an integral of u minus 3 and then a bu plus c u squared plus 1. So I set it up. And then I blah, 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 did some math with what I had. And my a equals 1/10. My b equals negative 1/10. And my c is equal to negative 3/10. Now, so I did skip a lot of steps. Okay, I did. I could plug them into this guy now. And so what I actually end up getting is 1/10 u minus 3, negative 1/10 u plus negative 3/10 all over u squared plus 1 du. Okay, cool. We've actually seen this before. What I'm going to do again is split these up into 2 separate integrals. This one here is super easy, so 1/10 ln of the u minus 3. On this side over here, I got my negative 1/10, and then my u substitution will have a 2 in the front. Again, I'm skipping a lot of steps here, so you actually get a 1/2 ln of the u squared plus 1. And then on this final side over here, my negative 3/10 just sits in the front. He's going to be an arctangent, but because everything's a 1, that's a 1, 1, and everything's a 1, it makes it really simple. So arctan of just u, and then plus c. We can't leave the u's. We have to replace them with e to the x. And then we're finally done with this problem. I skipped steps. I admit it. I skipped some steps here. We've done a lot of these already, so now you kind of know what to do. And at least now you have a guide for this particular problem on how to accomplish it. So there you go right there. All right, and I'm done. There's other ones that are tough, but it just is relentless, man. So literally just do the best you can. That's all I can really say. Just do the best you can. If you have any questions, ask me. I'm here for you. Thank you very much. Have a great day.